Hello, I'm Matt Eland, and this is How Do You Tame a Big Old Ball of Mud? For those of you not familiar with the term, big old ball of mud typically defines a system that has become so interdependent and so convoluted and complex that it's hard to make heads or tails of. It's usually used by software architects or people talking about software architecture. We're not going to be talking too much about software architecture today. Instead, we're going to be talking about testing, and specifically .NET testing. So how do we tame these legacy systems which we inherit, or if we create these systems, how do we take care of them? So I am an instructor at Tech Elevator, a boot camp in the eastern side of the United States. I'm also on Twitter at IntegerMan and on LinkedIn as well. But if you do send me a LinkedIn request, please mention that you found me from this video because A, I'd like to know that, and B, I'm more likely to accept it. I also write frequently on software quality and software development at killallDefects.com. So, with that said, let's talk about this talk. So, I'm not going to be getting really deep into any specific technology. My goal here is to expose you to as many different types of tests that you can do inside of the .NET framework, inside of .NET Core, specifically with C#, but many of these things would apply to other languages such as Visual Basic or even F#. So I want you to understand a little bit more about a lot of different things and give you resources to really look into these things if you want to learn more. So really, I want to give you some tools to do your job better. This talk is the result of me looking for any and all ways to improve the software quality of my team when I was a software engineering manager before I transitioned into instructing. And so I hope you find at least some of these tools useful in your own journey. So we'll be starting talking about basic unit testing. We're not going to be covering that too in depth, as I assume many of you already have basic knowledge of that. But then we're going to get into improving these unit tests, tools and processes that can help you with your own journeys as well. But the bulk of what we'll be talking about today is just really improving these unit tests and the types of unit tests that you can do. So our examples today are going to be focusing on a fictitious system that takes in a resume and it spits out a concrete score for how well suited that resume is for that score. This would be my resume from a few years back when I was looking for an Angular team lead role, by the way. So what do you do when you inherit a system that's got 50,000 lines of code and all these horrible defects? You're probably not too wild about it, and it's not like you necessarily have the testing infrastructure. So I'm gonna talk about the options that we have available in front of us. Oh, and by the way, they need us to add this one new feature. This is stuff of nightmares right here, and I've been there, and I'm sure many of you have as well. So when you're put in this situation, which you will be at some point, what do you do? Well, obvious solution is you could quit. You say, hey, not my problem anymore. I'm going to find a different place. Another possibility is you could fail. Failure is always an option, unfortunately. Alternatively, you could try to do it and just get so stressed out that maybe you wish that you quit or get burnt out. But I would say that there's a better way than all four of these options. And that is we need to build our own safety net, and then we need to resolve the issues that we're encountering. So that's what we're talking about here today. So unit testing 101, just want to help you understand unit tests if you've not worked with them before, or maybe if you're a non-technical person. So this is a .NET unit test. So this is a test saying that, hey, Matt Eland should always score well when being put through the system. There's a little bit of an egotistical rule, but hey, it's my talk, right? So you notice here we have arrange, act, and assert. Well, that's kind of interesting. We'll talk about that in a second here. But first, let's look at this little fact attribute at the top. This tells the XUnit testing framework that this method is a unit test. So when it builds this project, it says, hey, I found some things here that look like unit tests because they have this fact attribute behind them. Okay, well, cool. Now I'm going to run this as part of my testing suite when we're running our unit tests in Visual Studio, or as part of our build pipeline, for example. And next you see here, we're actually executing our code under test. So in our act section here, we're saying, hey, analyzer, analyze my resume. This is what we're testing. We're testing that the analyze method on this resume analyzer spits out an appropriate response. And the way that we're verifying that is with this assert.equal statement down here. So assert.equal, we're saying that, hey, the score of this thing should be the maximum integer. Again, my talk, my examples. Let's just say that this is something we would expect of a system. You never write a system this way, even though I might appreciate it. Now, again, we're following arrange, act, assert. This kind of helps clarify exactly what you're testing, which is the stuff under the act, and it also illustrates what's set up versus what's actually under test and what's verification. So I like to explicitly put these comments into code, but not everybody does that. Just in general, try to separate these things because you're going to have better code long term if you follow this type of a pattern, even if you don't use those comments the way I did. So let's talk about test-driven development, or TDD, as we hear. This is really, you start with a red test. That's a test that fails. So I might say, let's say we have a new requirement that says people with the last name of Smith should score 10 additional points. Horrible rule, but good example, right? So we would just write our unit test with a name of Smith and maybe somebody with a name of, I don't know, name is blanking here, Davis. We might score someone with Davis and then score someone with Smith and compare the two of them just to see, like, okay, Smith is 10 points greater, yeah? And then the test goes red because we haven't actually written the logic to increase the scores of anyone with the last name of Smith. So that's our red phase. Green phase is we take our failing test and we make it pass with the simplest amount of code possible. So we go in and we would add in a rule that says, like, hey, if your last name is Smith, I'm going to add 10 points. And then we run our test, and now it's green. And this last phase here, refactor, that means we're cleaning up our test code, and we're cleaning up the code that we added. So refactor means to change the form of something without changing its behavior. So we're kind of making it a little bit more reusable, a little more documented, etc. So that's red-green refactor in a nutshell, where you're just iteratively adding tests for these features that you're adding in and making them pass and cleaning everything up. And this builds up over time because you have this suite of tests that can catch new failures, which is awesome. That's what you want. Okay, so you hear developers whining about unit tests. It's like, I can't write my test because blank. And developers are creative, so they have a lot of different things. So let's talk about some of these. I can't test my code because of blank. So I can't test my code because it works with the user interface. So some options. Well, you could say, hey, we're not going to write unit tests around the user interface. We're going to have our quality assurance people do that, or we're going to do something like that. That's a valid option, but you need to make it an intentional option and discuss it with your team, including quality assurance. You could make the view layer as small as possible, and then not test that, or test it a minimal amount, and then unit test everything else that's in the back end. I like this approach generally. But if you absolutely must test the must test the user interface, I recommend that you add in automated user interface tests through user interface testing suites. We'll talk a little bit about Selenium later, which is one form of that, but there are many others, and that's a field that keeps growing and changing as well. Other thing you hear is, I can't test my code because it works with database dependencies. Okay, well, you could remove the database dependency via dependency injection. So this means instead of taking in a database connection, you might just take in a list of objects, for example, and you're just writing your test using the list of objects instead of providing a database connection. So that changes what you're actually testing. There's also some other approaches, like you could use entity frameworks in memory databases for your unit tests if you're using entity framework, which I do recommend. We'll talk about this a little bit later on in this talk today. And then you could also just, hey, keep talking to the database, but we're going to work around the database dependencies by making sure the database is spun up prior to unit tests run, making sure the database starts in a pristine state so the records that you're looking for are there or they're being created on the test start. Generally, I prefer options 1 and 2 here instead of option 3, but you do have options, so database dependencies shouldn't prevent you from testing things. And finally, I can't test my code because it's a big ball of mud. So, jokingly, you could get good. Not typically an option, at least not on the quick phase of things. You could also say, hey, I'm just not going to test anything. But you should expect your users to find the things that you didn't catch. And then our serious answer here is put in what I would call some pinning tests that would pin the current state of the application in place, and then you refactor it to a better architecture. We'll talk a little bit more about these pinning tests later on here. But this is highly what I would recommend. This is what I'm talking about with the safety net, is you want to pin the current application behavior, right or wrong, so that when you're making your changes later on, you know that you changed something in as far as how the application behaves. Cool? All right. So let's talk about this. How do we tame our big old ball of mud? Well, we build the safety net, which we talked about. Now we're going to improve the testability of our code. Now we're going to improve our unit tests. And then we're going to refactor the code and then expand our unit tests. And we'll talk more about solutions in each one of these 5 areas and then conclude at the end. So building a safety net, right? We want to pin our current state. And one of the ways you can do this is with a library called Snapper. Snapper is very similar to Jest on the JavaScript world, if you're familiar with that. Snapper has what we call snapshot tests, which you see down there at line 41. We said, like, hey, my result object should match a snapshot. Now, what that means is the Snapper library is going to serialize the result object to JSON, and it's going to compare it to a previously saved JSON representation of that object. If those objects are different in a significant way, this test will fail, and you will get a failure in your unit tests, and you'll know that, hey, I changed something that I didn't mean to. Maybe there was a bug in that snapshot, in which case I can just uncomment this attribute on line 29. I can say, hey, update my snapshots, and this is actually how you create the initial snapshot. But you say update snapshots, you rerun your test, and then it will regenerate that file, and your test will pass again. You'll then commit that snapshot into source control, so the next person to pull it down has that snapshot to compare it to, and you'll comment back out line 29, so you're not updating the snapshots every time. So this lets you catch things that you might not have explicitly been testing around. So let's say the name of the person that the resume is attached to changes somehow to Bob Smith every time you run the analyzer. You don't necessarily have a test around that, but this will catch that. It's like, wait a minute, this resume is no longer for somebody, it's for Bob Smith. This test fails. And that's what you would want to happen in this case. So Snapper is good for very broad tests to really get you spun up quickly, but you notice this test doesn't really document a lot of its behavior. So you don't want a lot of Snapper tests, but they can be very helpful for getting broad tests that other things might not have covered, especially as you're just getting started. Earlier I mentioned Selenium WebDriver. This is a way of actually testing the user interface. So what we do here is we write a test to open a web browser. This can be a virtual, like a headless browser, which doesn't actually open something on the machine that you can see, but it opens it in memory and it uses it to browse and compare things to. And you just define how you want it to work. So here I'm defining a Chrome driver as my web driver. So this is going to use the Chrome browser. And next, I'm saying, like, hey, I want you to navigate to this isitfriday.org website, and then I want you to find the element with the ID of isitfriday, and my assertion on line 29 should be null. So it should always say, no, it's not Friday. That's my unit test here. This test has always passed whenever I've run it, but I've never run it on a Friday. So this is a bit of a joke test, but you can kind of look at this and say, like, hey, I can use this to navigate out to a specific page, and test that I see certain things on that page. And you can use some more complex class-based tests that Selenium has with it as well. I'm not a Selenium expert, so this is just a very surface-level introduction to this is a thing that you can drill into. Most of our tests today are going to be talking about back-end testing and just generic .NET testing. But here's something that's not back-end testing. This is looking at web traffic. So you can use Fiddler to analyze any outgoing traffic from your machine. So let's say I'm writing a service or a console application or something like that, and it gets a request and it makes a series of web service calls, and I want to look at what those calls are, the order that they're coming out in, what's in the body going out, and what's in the response as well. So Fiddler will let me inspect those things manually and just really start to understand more of the way my application is behaving. I can then actually save a snapshot of kind of how of a series of requests, for example, to what's essentially a zip file of text files, and then later on I can go back and I can compare that to the current behavior. There's not really an automated way of doing that I know, but you can look at this and say, like, hey, did our web service behavior change, without having to mock an external API or something like that. So Fiddler is very good for finding out what a service is doing as far as communicating to other things by capturing traffic coming out of the current box and how that flows and what responses you get from that. I've had very good results with using Fiddler to coordinate between different teams and different services and analyze web service communications, for example. Postman is another one that you think of with API testing, and Postman has some automated ways of building out requests and verifying that they pass. So you can use Postman just for about anything you want as far as API testing goes, which is really cool. They have a lot of custom syntax and things like that, which you can use. I believe it's actually built on JavaScript now, which is pretty cool. My natural reaction towards Postman is that maybe it's more geared towards your quality assurance team than your development team, but it does let you do things in a repeatable way, and you can even schedule it to run every hour or 3 hours or whatever you want, which is really good. I've used this as a kind of a poor man's health check before on some of our quality assurance and user acceptance testing environments at prior roles, and that works very well. The user interface is very nice too. So this is really a good tool for helping people understand Web API and requests and responses in general. It's part of how I like to teach that. All right, so let's transition now into improving the testability of our applications, because applications typically when we're starting to try to test them, they aren't all that testable. Makes sense. So let's look here at removing database dependencies. So here we have a method that's talking to the database. You see line 36, we're building out a new SQL connection. We're building out a new command on line 39, and then we're building out some custom SQL on lines 41 and 42 and executing that. So this is code that's always going to be tied towards interacting with a database. And all we're doing here is we're finding keywords and how much we should penalize or reward them when analyzing a resume. So instead of doing this, what we can do is we can introduce something like an interface of iKeyword bonus provider. So this is like, hey, I want you to get keyword bonuses. So really this is effectively what we were doing here. You see the dictionary we have on line 33 that really corresponds to this definition here on line 9. So we're going to representing prior logic in this interface, and then we're passing this keyword provider into something else, and we're saying like, hey, load your bonuses on line 34, and it just kind of abstracts away that logic from the calculate score method here. So here on line 34, we don't need to worry about talking to the database because all we know is we have something that will get this information for us somehow. And maybe when we're testing this, we can provide it a statically coded keyword provider or something like that. And that would look something like this. So here's a fake keyword provider, and that just returns back like, hey, if you see testing, give us a 5. If it's an XUnit, give us a 5. Unit is 5, and MS test is a little less respected, so we'll give it a 2. So sorry. But you see, this is a way of removing the database dependency from everything else, and this data actually looks like the data in the database, which is pretty cool. So let's talk a little bit more about how you might provide your keyword bonus provider to your application. You would use something like an inversion of control container, or also called a dependency injection resolver. And here I'm going to show you AutoFac. .NET Core has kind of built-in IOC dependency injection support, but if you're using .NET Framework, you kind of have to add your own, and AutoFac is really the leading way of doing that. You can do it in .NET Core as well. There's just a lot less reason to, because .NET Core has some really good built-in stuff. So here we have an iContainer, which we can use to provide values. So we're taking in the iContainer. This is our dependency injection container, and then we're using it to resolve the iKeyword bonus provider. This is saying like, hey, however we've configured this container, we want to pull the iKeyword bonus provider out of that container, and that's going to say, okay, well, I know this is production, so I'm going to give you the SQL Server keyword bonus provider. Oh, hey, this is a testing environment. I'm going to give you the fake keyword bonus provider. So this is how you would grab that value and provide it on to the calculate score routine. The way this would look is you would build out this container builder, and then you would just register your keyword bonus provider as that value. So this might be a new fake bonus provider, or maybe a new SQL Server builder provider, something like that, or bonus provider rather. Typically, you wouldn't take this in as a parameter. Here, you'd actually instantiate it inside of this, or just give it the type when you're registering things. But see AutoFac's excellent documentation on GitHub just for more information on getting started with this. And then finally, before you return anything, you need to actually build out the container. Otherwise, you're just going to be returning a container builder, which you can't use to resolve anything. So this is what says, hey, we're done configuring this thing. You can now go and run with it. So that's pretty cool. All right. Kind of related, but a little different, is mocking. So mocking is a way of configuring object behavior, let's say. So here we're going to mock out the iKeyword bonus provider. So we're saying, hey, I want a new mock using mock MOQ, or sometimes called mock-u. I like mock better because it sounds more like what it's trying to do. And then we're going to set it up, and something like, hey, when you're calling the load keyword bonuses method, I want you to return a new dictionary with these values. This is really kind of getting at the weaknesses of mock, in my opinion, which is it's very hard to understand what mock is doing. To someone who hasn't worked with it before. Mock is very hard to read because it uses expression syntax, like we see there with the provider lambda expression. And then we also see things around, people just get confused around how mock behaves, but it does let you build out some very powerful things. Typically you'll need to abstract that away into like helper methods or things like that, so people who are writing tests don't get too concerned with how the mocks are configured. Okay, so let's talk about how you use this mock. right? So now that we have our mock, now we're saying like, hey, we're going to take our mock iKeyword bonus provider and we're going to provide it into the analyze method. And that just provides an iKeyword bonus provider, which is mock under the covers. And it's going to behave exactly as how you configured it. Mock is a very complex topic, so I'm really trying to stay at the surface level. And it is one that tends to trip people up. If this is something that is confusing you, please feel free to reach out to me on Twitter at integerman, or even by email at matt@killaldefects.com. We can talk more in more detail, and I can go into this in a more dedicated video if you'd like. But this is really what mock lets us do. Now, mock also lets us do some very cool things on verification. So let's say that I want to verify that this analyze method called the load keyword bonuses method, and it only called it exactly one time. And so this last line here lets me do that. I'm saying, hey, mock, verify that we called this method, and the times that it was called must be exactly one. So if it was never called, this will fail. If it was called twice, this will fail. The community is a little divided on whether or not this is a good practice, because typically you want to validate behavior through the result and not through assertions on a mock. But mock does let you do this, and there are circumstances in which you would want to do this, depending on how your application is architected. But just know that this is a little bit of a divisive thing. Mock is one of the more advanced things we'll be talking about today. Again, reach out at this if you need a little bit more help understanding this. And it could be that just mock is not for you and your team, and that's fine. There are other alternatives around that. All right, so let's transition a little bit into Entity Framework. I mentioned this earlier, but you can use Entity Framework, which is a data access object kind of a thing. It's a middleman between you and the database. So Entity Framework represents your objects in your database tables as objects or classes, and then you can use it to query the database using things like link, and it will generate the appropriate SQL. And so that helps you not have to worry about certain types of things when working with databases, which is pretty cool. But in addition to working with databases, you can actually use an in-memory database. So here we're saying like, hey, I don't want you to have to talk to any sort of database. Just use an in-memory database. We're going to name it something. That's fine. This is for its own internal usages. And then we're going to work with it. So here we're going to add some data to it. And then we do need to save the changes that we make so that other queries against this can find it. So this is just saying like, hey, I'm going to add 4 records. It's going to be available to anything else running with this. And the other unit tests that use this that use this database context will be able to find this. They'll be able to find this data. So you can kind of set up some in-memory data that's always going to be there every unit test, and then work as if you were querying against a production database, but you're really querying the in-memory database. So this is really more of a setup kind of code when you're generating a Entity Framework context for your test code to use, if that makes sense. All right. So some of that advanced stuff out of the way, let's talk about improving our tests, making them a little bit more useful. It's always important to refactor your tests. One of the things I like to do is I always like to use a base class for my tests. And that lets me kind of introduce shared methods that can be shared across multiple different things. It lets me hide some of the complexity away from the test, so we can really focus on what actually matters to that test. And so here we see the analyze method. That's just something that was that's defined inside a resume test base, and it just says like, hey, you give me your resume, and I'll do everything I need to create the resume analyzer, give it with a good testing context, use in-memory databases, whatever I want to do, You just give me the resume, I'll analyze it, spit back a result, and you can verify things on that result. And this makes sense in this context because you really just want to focus on, hey, here's a resume, what are you going to spit out? And that helps you focus on what actually matters. And if you do need to change things, you only have to change it in the analyze method instead of in every impacted unit test. So I would strongly encourage you to do this. A library I usually will use when I'm working in .NET is called Shoodly. Apologies, this is actually a little bigger than I thought it would be, this screenshot here. But Shoodly lets you avoid this assert.equals syntax that we talked about earlier. And this is a little bit more human readable. So we see score should be max value. Resume should not be null. Resume should be the resume that I gave you earlier. The jobs count should be less than 1. Okay. So very human readable. So I really like Shoodly for that reason. Shoodly is less popular than another library called Fluent Assertions, which does very, very, very similar things. I happen to like Shoodly syntax a little bit better, but this is a little bit more popular. And you see here we use should and then .b, but they're very similar libraries in general. So use whichever one you'd like, or use neither of one of them. But they're there to help you, and they help make tests a little bit more readable and document the behavior a little bit better. So let's talk about clarifying your tests a little bit more. There's a library called Bogus, which exists to generate random data or fake data. So if you have something which doesn't really matter to your test, let's say the name or the age of the applicant, hopefully shouldn't matter, as I'm advancing in age myself, you might just say like, hey, just give me a random number. That's cool. So Bogus lets you do that. So it'll generate random things for you and random meaningful things. So here, for example, line 39, we're saying like, hey, give me a new resume, and we're just going to call bogus.name.fullname. So it's going to generate a random name from its database of names, and then that'll go through your resume processor. It also has some interesting things like company name and hacker phrases. So you can use things like URLs, dates, serial numbers. It's got all sorts of stuff, and this is stuff that looks fairly spot on. There's some downsides to this in that you are introducing a degree of randomness to your tests, and so that if some of these things which you think don't matter, like your organization name, actually turn out to matter, that can generate some failures that you're not expecting, and it can be hard to recreate those. So be careful when you are introducing something like this, because it can introduce random failures. So only use it for things that actually don't matter. And it's actually a good way of finding out if they do matter or not, because it adds a certain degree of additional testing to your test suite at the expense of it's harder to predict behavior of your test suite. That makes sense. There's a lot of add-ins for Bogus as well, so I do encourage you to check out all the things that they offer. You might find uses for Bogus within your production application, especially if you're prototyping. So who knows? You can also just do simple things like random numbers, which is pretty cool too. So you don't have to really worry about how the random number generator is set up. You just use it, which is great. I always like that. AutoFixture is pretty cool. This lets you just create objects just out of nothing. Very similar to what Bogus is doing, except a lot more hidden under the covers. So here we're saying, hey, fixture, create a new object for me, and it creates a new resume info object, and it populates it with really with dummy data. So we see here with the name of my field and then a GUID attached to the end of it. So less meaningful things that Bogus would do, but less work involved as well. And it created a random integer for my months in the job field. So that is AutoFixture, and that's very much worth checking out as well. You can configure its behavior beyond this, but just out of the box, it's going to say like, hey, Okay, you want a resume info? You say it doesn't matter what's in there? Cool, here you go. Here's one. Use it. So very useful for getting set up on things, and that can help you bypass the database as well if you want. All right, so how do we refactor our code and do it safely? So not just about test code now, assuming that we're making changes to our code, that we're trying to clean up this big old ball of mud that we have, how do we do it safely without bringing down production? So typically when you're retiring a legacy piece of code, you do a deployment. So I'm going to get rid of my legacy routine and I'm going to introduce a new routine. Okay? Well, great. But what happens if you made a mistake and things are suddenly broken? Well, now all of a sudden production is broken. Users are angry, your boss is angry, everyone's just generally unhappy, and you need to urgently do a rollback. And maybe there might be some advanced data migration that needs to happen because of that you really weren't planning around. So that typically doesn't work very well in my experience. And so there are some things you can do to try to mitigate that, and I want to share some of those with you. So you can use feature flags, which is basically just I'm going to have a setting that says, hey, I want you to use the new routine. Okay, great. We're going to use our new routine. That's fine. We'll keep the legacy routine around possibly. And then if we find out that the new routine is buggy, then we'll just change our config file and it's going to go back to the legacy routine. That's pretty cool. The downside of this is you do have to test both the new logic and the old logic, as well as switching from the old to the new and the new to the old, in order to make sure that you're really not introducing bugs by having feature flags. I've seen feature flags hide bugs in quality assurance environments by features that work in certain modes but not others, just due to database dependencies or things like that. So if you're using feature flags, you need to do maybe 4 times the amount of testing that you would if you're just doing a flat out rollout or a deployment. But they can help you hedge your bets a little bit on this type of a deployment. There's a library called Feature Toggle. There's actually a lot of libraries like this. This is the one I like to recommend because it makes it less likely that you'll make a mistake. So Feature Toggle gives you these little toggles, which are configuration based, and they say whether something should happen or not. So here's a use new analyzer class. So this is representing that flag we just talked about, and this is a simple feature toggle, and this is implemented fairly easily. And then let's say we're going to grab our resume analyzer. So which resume analyzer do we want to use? We're going to say like, hey, if our use new resume analyzer feature is enabled, we're going to use the rewritten analyzer. Otherwise, we're going to use the legacy resume analyzer. The syntax of this on line 20 is a little hard to read, but that's just a side effect of a feature toggle in general. The benefit of this, however, is that you don't have to deal with strings in your configuration files. You don't have to deal with magic strings being possibly wrong or missed or things like that. And it just reads from your app settings JSON in .NET Core or your web config. So here's the JSON file from .NET Core. We just say feature toggle use new analyzer, and that's the name of our class. And this tells us okay, we're going to use the legacy one here. So feature toggle is very nice. Its syntax is a little weird, but just look at it through the lens of it's designed to make it hard for you to make mistakes, to make silly typos and things like that. Okay, so let's talk about canary testing. So canary testing is very similar to a feature toggle, but we have something like, are you a beta user? If you are, we're going to give you the new routine instead of the old routine, and that way if there's an error in the new routine, only a small subset of our users who were beta users are affected. So that lets us roll out patches to this thing before we spread it out to larger and larger sets of our users. And maybe you don't do this as a code flag, but you say like, hey, you're going to use server A, you're going to use server B, you're going to use server C, and some of these things get updated more frequently than others. Larger organizations like Facebook will do this, I know, but probably others as well. which helps you just kind of test out features on a small subset, which is nice. One of the things I like, and this is probably the best thing I discovered for software quality in 2019, when I really went nuts just understanding and exploring all the options I had available to me for this sort of thing, is called scientist.net. And scientist.net is it's part of a family of libraries called Scientist, maintained by GitHub. Not on GitHub, but actually by GitHub and on GitHub as well. But regardless, Scientist.net is a library that effectively says, okay, we're going to write a little piece of code that says, hey, I have a science experiment. Here's my old way of doing things. Here's my new way of doing things. We'll see the code for this in a minute here. But what this does is it's going to call out to both your legacy routine and to your new routine. And the results of that are going to come back, but only the legacy result is going to go back to the client. So this lets us compare the legacy and the new one. And what Scientist does, well, we'll talk about that in a second. So what happens here, the reason why this is valuable, is if my new routine has some bugs in it for a small subset of data or a small subset of users, well, that doesn't really impact anybody because the failure just goes to Scientist. The old result still goes back to the user. They have no idea something went wrong under the covers. But that failure can go to something called a results publisher, which can log things to a database, the console, the event log, whatever you want to log to. I like to use exception logging services like Raygun.io or Rollbar or things like that, where you can actually track these exceptions as they come in with like details on the request and just kind of nerd out over the frequency and patch them at your leisure. And once you're really sure that everything's good, then you can remove the legacy routine in Scientist.net from the picture entirely and just use the new routine. But this lets you safely roll out new features with the downside of you're rolling things out a little bit slower because you're going to have to go through this data collection process. And that can be hard. Not all teams are ready for that. Another thing you have to keep in mind here is that because the legacy routine and the new routine are both actually executing, if they have side effects like inserting rows into your database or sending emails or making requests to external systems, those are happening twice. So you can't use Scientist in those cases, or you need to re-architect your code a little bit to optionally not do that on the new routine, or just kind of take that dependency and move it back out to the client, where the client will then take the results of your routine and send it on to something else, like an email sender or something like that. Scientist actually works pretty well from a unit testing perspective. So this result publisher can actually fail things, and it can fail your unit tests. So you can write a unit test as like, hey, here's my old way of doing things, here's my new way of doing things. And the only person who's using Scientist is the developer, who is he's or she is just really going through your code and refactoring it. I've found a number of issues using Scientist.net to test my theories on cleaning up code, and it really saved me some huge embarrassment and customers from some huge issues just by being scientific, pun intended, about the way that I refactor code. So let's look at some of this code for Scientist. So we have this little section here that says, hey, scientist.science, so it's going to run an experiment, and the result type is going to be an analysis result. So that's my domain object here. And then I'm going to give it the name of the experiment, in which case this is just the name of the method they called it. And then I'm going to give it a function to configure this experiment. So lines 26, 27, 28. This is the legacy routine that you are using. So use my legacy analyzer. Then this is the experiment I'm trying. So use my new analyzer. And here's how I want you to compare these two results. So just look at the score and see if they're equal. If they're not, well, something changed, and then that can go out to a result publisher. So here I have a result publisher, for example. So I'm going to set my Scientist result publisher to the new throw if mismatched publisher. This is a custom publisher that I wrote. And you actually don't necessarily need to do this anymore, but this is what I was doing at the time just to help me with unit testing. One note here is that scientists will wrap things into aggregate exceptions, and so you kind of need to look at the inner exception and then rethrow that exception. Unfortunately, otherwise you don't get a good, meaningful test. But I believe scientist actually has a fail unit test or something like that property on it now, which it didn't before when I was working with this initially. But let's take a look at what a result publisher might look like. So this is my throw if results mismatched publisher, and this implements result publisher. The signature on line 10 is very hard to read. Just the T and the T clean generic syntax. Don't worry about that too much. Scientist needs that signature, but you don't have to be concerned about it too much here. And so what we'll look at here is we'll say, like, hey, if my result was mismatched, then I want to start building out something and throw an exception. So we'll say, hey, my experiment name had some mismatched results, and then for each observation, this is actually each experiment that I tried, which is going to be 1, because we're only doing one experiment in my example I just showed you. The value was 4, and it should have been 2. Whatever it was, right? And then line 22, we're saying, like, hey, this, we're actually just trying to cause an assertion failure here. Again, you don't need to do this in Modern Scientist, but at the time in which I generated this code, you did. Scientist has a nice little helpful unit test property on it now, which you could do instead. But just take a look at this syntax here. You don't necessarily need to be throwing anything, but you could log something to a database, log it to console, make an external web call, whatever you want to do. So that's scientist.net. Check out killalldefects.com if you want to learn more about scientist.net. I've written a lot on the topic. I really love the library, and my examples there are pretty detailed, a lot more detailed than these slides. So highly encourage that you check that out. And I do talk about that unit testing property in a little bit more detail there as well. All right, so let's talk about expanding unit tests. So now that we have some unit tests, we want to make sure they, we get the most bang for the buck out of them. So let's say you have a lot of very similar unit tests. This usually happens, copying and pasting unit tests. It happens all the time. Usually, you might have a resume for Dylan, and one for Caitlin, and one for Matt, and one for Freya, or whomever, right? And you'd have some slightly different assertions for each one based on the behavior you're trying to verify. Well, you don't necessarily need to do that. You can use XUnit's inline data attribute, which lets you pass in parameters to things. So here, for example, single job should score for number of months in job. So the number of months I spend in that job should be the score I get out of that job. So instead of writing one that says, hey, here's 1 month and your score should be 1. Here's a 3 month, your score should be 3. We're going to take in some parameters here, and this inline data that we're providing is going to be fed into each one of those parameters. And note here that we're using theory on line 7 instead of fact. Theory is the attribute you use when you're working with inline data, versus fact is there's no parameters. Just a small little distinction there for you. So this is a really good way of scaling up your unit tests without having to duplicate a lot of code, which is pretty cool. And so you can pretty easily duplicate the inline data attributes to add a new test case. If you don't want to if you have a lot of these things, or you might have a wide range of values, you can use a class data attribute here. So this class data says, like, hey, I want you to use an integer range generator class. Syntax there's a little bit weird, but we'll look at that in a second. It's still taking in a number of months, and it's still asserting in line 40 that the number of months should be the total score for the job. So it's really a very similar type of thing, only we're using an integer range generator. So let's look at what that is like. So this is just an IEnumerable object array generator, and what we do is in our getEnumerator method, we are then just yielding new values. And that integer type, even though it's wrapped in that object array, this is part of why I don't like XUnit's implementation of this. InUnit does it a little bit more simple, but you can do this kind of thing in XUnit. This is how you do it. So this object array here, that corresponds to the number of months. So that int num months is going to be equal to that yielded object, where each value in that array is going to be the parameter that we're spitting back, if that makes sense. So if we had multiple things, we could spit back something with multiple values, which would be mapped to each parameter going in. So in this case, this is going to give us values 0 through 49 as inputs to our test method over here. And you wanted to tweak this a little bit, you can. So integer range generator is just a way of demonstrating a class data provider, and that's just really just an IEnumerable of object array. Syntax is ugly and not that readable, but hopefully you don't have to work with it and tweak with it too much. But it's there if you can use it. InUnit has some really cool things to do this a little bit better, which is cool. All right, so SpecFlow is what's called a behavior-driven development, or BDD framework. This is similar to Gherkin style syntax or Cucumber, if you're familiar with that in other languages. And this is really a more human-readable unit test that has code underneath it behind the covers pulling the strings. So let's talk about this file. So line 1, feature, months, and jobs. So this is really a feature file. So this is the things that we're testing in this file. Line 3, this is a free text description, doesn't matter for anything, but it can help the business analyst or quality assurance person or developer who's looking at the file understand a little bit more about what we're trying to do here. Line 5 is at scoring, so this is really just a tag that's applied to this. Often you'll see tests without tags, but just know that you can have these little attributes on here on your tests for categorization if you have a lot of tests. And then you just make up a string to put next to it. So I can have, I don't know, at job hopper or something like that, right? But the real meat of this thing is lines 6 to 9. So let's talk about those. So scenario, months, and job. That's the name of our test. And then we have given, when, and then. These keywords are telling us, it's telling SpecFlow to look for actions corresponding to these things. So given a resume, when the candidate has held a job for 14 months, then their score should be 14. Okay? Very human readable. I can give this to a business analyst and they'll be able to understand it. They can probably, even with practice and training, they can write this stuff, you know. What SpecFlow lets us do as developers is it lets us define these steps in our code, so we can say we're going to give it a regex of given a resume. So this corresponds here to line 7, given a resume. Then we're going to map to this. So when SpecFlow compiles and it sees this, it says given a resume. Okay, all right, and go down here to given a resume. Okay, so I'm going to define a new resume instance. And then I'm going to say, all right, let's take a look at our when and our then. Right, so when the candidate has held a job in 14 months, then their score should be 14. Okay, this is what this looks like in SpecFlow. So we say when the candidate has held a job for blank months, and then you see that int months parameter on that method. So SpecFlow is just saying, like, hey, you see that value come in, I want you to map it, you know, to these parameters. And then that'll let it get into this method as a parameterized thing. So using this logic, I can actually write something in here that says, given 1 month, then it should be the score of 1. You know, as long as a business analyst is writing something that uses the same sort of a regular expression, same sort of a pattern, it's going to get picked up by these things. And note before I go any further here, SpecFlow is compile time generated, so you can't really have it be like dynamically loaded on an existing application, but you can incorporate tests from external people into your process when you're making a fix or adding a new feature, and then making sure those compile. So when the candidate has held the job for for months, that's where we're actually building out our job. And we're adding it to the existing resume that we created in the given step earlier. And then finally, then my score should be expected. That's saying we're actually going to do a test. And here we're just using shouldly style syntax. We're saying, hey, result score should be my expected score. Pretty cool. So that's really the power that SpecFlow gives you. And it lets you write these tests or have other people write these tests and be involved in your process and have your tests be very human readable. Now behind the covers, it can look a little dirtier as you're using regex, and you might have a lot of different types of steps definitions. But this is something that you can consider with your team if this makes a lot of sense, given your organization structure and communication habits. But it helps other people get involved in testing, which is really the main point. All right, so let's talk about some non-code ways of improving your processes. So you may have noticed these little green bubbles on the left side of my examples. And this is from a tool called InCrunch. InCrunch is a commercial software product. It's a Visual Studio add-on, and it will let you just run unit tests whenever impacted code changes. It's going to run them under the covers, run them on different threads, or different processor cores rather, sorry. And it's going to help you understand things. So here you see all these green lines and these white lines, circles rather, and these are lines that are covered by tests versus lines that are not covered by tests. And you also notice this little kind of yellower bubble at the top there next to the load keyword bonuses. So this is just saying like, hey, this took a little bit longer, and if I mouse over that, I'll get some more information on exactly what happened there. And then again, these white bubbles are like, hey, this is not tested right now. You should consider adding a unit test to this. So InCrunch is really, really cool. If you're doing a lot of testing and a lot of test-driven development, InCrunch is a very cool thing to check out. They have a free trial. I would encourage you to check it out if it sounds like something that you might be interested in. Let's talk about JetBrains. So JetBrains makes things like ReSharper, Writer, IntelliJ, WebStorm, lots of development environments. I'm a big fan of them. I've been a big fan of them for over a decade at this point. But they have this library called JetBrains Annotations, which gives you these little attributes like not null, can be null, and some other ones. And these can be used to decorate your own method return types. You can use them to decorate your parameter types, and this can help improve communication in your team. Now, it doesn't actually matter at compile time, but if you use ReSharper, you will get like you'll get these little things saying like, hey, you're possibly passing in a something that can be null to a calculate score method, which says that your parameter should not be null. That's only going to show up to people who are using ReSharper or Writer, but the very presence of these can be null or not null attributes can help your team document things a little bit better. C# 8 has some improvements to nullability as well, which I would encourage you to check out. I'm not going to be covering them in this talk, but it's really worth checking out because the language is really moving along steadily, and I love it. And you can use JetBrains annotations just by NuGet. You don't even have to install Writer or ReSharper or anything like that. Don't have to pay anything. You can just use this right out of the box. Or make your own if you want. It's not too hard to make a new attribute. Okay, so code reviews. Code reviews are actually one of the biggest things that I've found to impact team performance, to impact team competency, and understanding of best practices. So I always like to make sure that junior and senior resources are reviewing changes, including changes from their boss, including changes from the new guy on the team or new gal, including changes from the crusty veteran. So usually I'll have a couple people testing a change, and that helps spread out knowledge a little bit more, helps people feel more courageous about making comments, helps the juniors see how the seniors are giving the code review comments as well. And I think it ultimately helps people not feel attacked in code review, which can often be a problem. Of course, you also have to make sure you don't actually attack people in code review for people to get that impression as well. But code reviews really help everything on. So making sure that every change is tracked, every change is going to be reviewed, it really keeps a sense of honesty, and it gives you an additional safety net, which is really what we're after. We want to give you as many safety nets as possible before things hit production. And you don't need to have code reviews with people in the room. You can have just at a desk as part of a pull request in GitHub or whatever you want to do. But you can do it formally if you want to as well, whatever makes sense for your team. Code analysis, I really like SonarQube and SonarCloud. I really like another product called Independ as well for just its code analysis tool sets. I don't have any pictures in this presentation on Independ, but it's worth checking out as well. But these are just platforms that will take a look at your code as it's committed to source control, and then it will automatically run code analysis and track it over time, so you can see trends of, are we getting more technical debt, are we getting less, what areas are we bad in, what areas are we good in, and so you can start to modify like the training on your team or your code review process or things like that, and start prioritizing aspects of your debt, which is cool too. And both of these products can look at code coverage statistics as well and see what areas are covered, what areas are not covered. I personally think Independ does a great job with that, so it's worth checking out for sure. Your build pipeline should be a big part of your testing plan. So anytime that code is committed to something that your pipeline cares about, it needs to build, and it needs to run the tests. So it should be able to fail the build when the test fails. It should be repeatable at any type of the day when the unit test runs, which means that you need to manage dependencies and servers which might go offline in the evening for a nightly build, for example. And then this can plug right into a tool like Independ or SonarQube, SonarCloud, and just really start tracking your changes over time. I like to use TeamCity as well for a build tool. It has some of ReSharper's code analysis built into it. It's not the best, but it can hook into things like SonarQube, SonarCloud, Independ, things like that, and you can upgrade that if you need to. TeamCity is free as well, at least for low usage or moderate usage even, which it's really great, and it's very good for .NET development, I found. So testing plans. This is a part where people get a little upset with me, but I feel like developers need to be writing their own testing plans. So before you're coding, you need to have a plan for figuring out whether or not this works and whether or not you broke something else. And that could be running your unit tests, it could be manually looking at the page, it could be writing new unit tests, it should be writing new unit tests. And then what I like to have is that developers provide their test plan in that code review, and then your reviewers will look over it and say, like, how are you assuring that this works? Oh, okay, well, that's a good strategy. Or, hey, did you think of this? And then where this gets really scary is you hand the feature over to QA to test it, and you're giving them your draft test plan. And then QA is saying, well, oh, okay, now I can understand this a little bit more. I can understand where you're coming from. I understand what this feature is. Or they say, like, well, did you think about this one? Or I'm really not sure that we're adequately covering this case. And that helps QA understand things and get up to speed a little bit more. It helps developers start thinking more about quality throughout the development cycle, and it just really gets the team working together. It might not make sense for your organization, but I've found good dividends from this approach. Functional programming, not going to talk a lot about it, but functional programming has a lot of things that really make it where defects are hard to exist. Sorry, my phrasing here is not that great, but things like null reference exceptions and discriminated unions, all these things, pure functions, immutable state, it's making it harder and harder and harder for defects to hide in your code. Functional programming is scary. It's a hard thing to learn. I've been doing code since 1987, and a year or two ago I tried to learn functional programming in F#, and it really hit my brain with a rock. Like it was very hard to learn some of these things. I'm still learning some things, but keep at it, because functional programming is really where development is starting to trend, and you can see that in the recent C# language releases. And it offers some solutions to some traditional quality problems that have plagued us as developers. Again, check out killallDefects.com. I write a lot about functional programming. I really think it's an answer to where we're going as a developer community, and it's exciting. But I can't really talk too much more about this at this point in this long talk already. All right, so let's conclude here. We talked about building a safety net, improving the testability of our code, improving the unit tests, refactoring our code safely, and then expanding those tests to bring others in and just scale things out a little bit more. My slides and code are available on GitHub. Really encourage you to check those out. And then if you have any questions, if you found something that works well for you for .NET development, please leave a comment on this video. Don't forget to like, subscribe, all that fun, catchy, normal YouTube-y stuff. But honestly, connect with me on Twitter and LinkedIn. Just let me know what you care about. Let me know things that are interesting to you and that I might not have thought about, because I'm always looking to learn new things. So thank you for tuning in, and just happy testing.